energy generation in many developed countries has been including renewable sources. These renewable sources are not as dependent as non-renewable sources due to their presence are not quantified and can't be predicted accurately. For example, a country both produce electrical energy through renewable and non-renewable sources, and the load, which is a housing area, has a constant demand of electricity. On a sunny and windy day, our grid will have excess energy due to the wind turbine, and solar panels are able to convert wind and solar energy respectively to electricity energy. Thus, overflowing of energy may occur particularly in our electricity grid. However, solar panels can't generate electricity energy in the night, thus production of energy decreases and causing a shortage of electricity in the housing area. A stationary, energy-dense, long-life energy storage will be the solution to the unbalanced supply and demand of electricity, as it will store the excess energy and supply it when needed. There are many roles of a chemical engineer in this crisis. One may be an innovator of new battery technology, or perhaps commercializing developed battery technologies in the market by inventing the mass production process, or even raising public awareness of this crisis through video making. Besides, since there is no process without potential hazards, chemical engineers can apply the principle of chemical process safety to evaluate and minimize the probability of hazards in battery systems. There are many roles of a chemical engineer, but today we will be introducing the stationary energy storage, liquid metal battery, which could be the solution to this crisis. So how does it work? The ceramic insulated cell contains the anodic metal, cathodic metal, and salt electrolyte. It is then heated until the highest melting point of the components are turned into liquid. Then, the positive liquid electrode will be the bottom layer, followed by molten salt electrolyte, then the negative liquid electrode. This is the charged state. During discharging process, the negative liquid electrode metal donates electron through the molten electrolyte and forms an intermetallic alloy, thus energy is supplied to the grid. The negative liquid electrode is fully consumed in the process and reaches a discharged state. During charging process, the intermetallic alloy donates electron to the molten salt electrolyte and allowing the formation of anodic metal, thus energy is absorbed from the grid. The cell housing, which is a positively polarized case and has a negative terminal protruding from center lid, are then assembled onto trays and connected within a thermal enclosure to form a MWH scale system, which is separately then coupled to the grid using standard industrial DC-AC bidirectional inverters. The trays are then assembled into a ready-to-install DC containerized system, which, complete with thermal management, weatherproof outer enclosure, and a battery management system, BMS, for applications that require high energy capacity, frequent cycling, long life, and high efficiency. For the economic value, it is more cost-effective compared to other batteries due to the materials needed are earth-abundant materials, along with its larger capacity to store energy, and more compacted storage proves that it can be financially worth to be invested in. Due to its liquid characteristic, thus the lifespan of it is much longer compared to its solid-state counterpart due to less chance of mechanism failure. Performance-wise, it was tested that its performance shows almost no sign of degradation, significantly overthrowing lithium-ion batteries' current performance. Liquid metal battery operates at relatively high temperature, 500 Celsius, but it is not heat sensitive, thus it will not cause fire or even explosion compared to lithium-ion battery, which has the risk of catching fire. Thus, it is safer choice for grid-scale storage. Cobalt is a key for boosting energy density and battery life for lithium-ion battery. Mining for cobalt in Congo has always been controversial due to child labor in cobalt mines, which leads to ethics issue of the mining activity and health issues such as lung diseases in the community. By using liquid metal battery, mining of cobalt can be ceased and restoring human rights and decreasing health issues concerning cobalt poisoning. Thus, liquid metal battery may be a better choice for grid-scale storage. If lithium-ion battery with shorter lifespan would be used for grid-scale storage, our waste generation will increase exponentially in the future. However, by choosing liquid metal battery for grid-scale storage, which has a longer lifespan, will reduces the generation of waste, or even no waste is produced, as it is 100% recyclable. We from 25 kWh believe that liquid metal battery will be the solution to this energy storage crisis, as it is economical and safe for the environment.